think we're live now. Hello, everyone. Thank you so much for joining us today. First of all, I'm Mel, and I just want to say sorry about some of you guys had a bit of a calendar issue today. I'm so glad you found your way here, and if not, you're watching the recording later on. So I'm here with Clayton and with Amber, who will be talking to you in a minute. And whether you've been following us for a long time or are new to WikiHouse, here is a reminder of why we do what we do. And it is to put the knowledge and tools to build beautiful zero carbon homes into the hands of everyone. And I was actually looking at our GitHub repo. I don't know if you can show that, Clayton, that actually shows you what we've been working on in the last few years. We launched Skylark in 2022, and here's like a little list of all the updates that we've been doing. So as you know, you're here because we are working towards version 1, and that is thanks to you and all your contributions. I'm going to hand over to Amber, who is ready to go. She's going to tell us about what we have been working on this year, and later on you'll hear how we're using our learnings to develop version 1. If you have any questions, just pop them in the box below and we'll get to them towards the end. So Amber, over to you.
Thank you, Mel. That's fantastic. So I'm Amber and I am WikiHouse Projects lead. So what I'm going to be doing now is talking through some of the amazing projects that we've been supporting and working alongside essentially over the last probably 12 months, really. Some have just sort of recently completed. So it's a really exciting time, I think, for us as a team where we are sort of, helping businesses and organizations to really get the best out of WikiHouse Skylark. And it's through those partnerships that the system as well has evolved and improved. And we'll talk about some of those improvements later on. So the first project I'm just going to show is an extension that we created with Duke Makes as WikiHouse manufacturer. So it's a residential extension, and we've got a little video here, which is nice to see those blocks kind of being brought in by hand. One of the really lovely benefits is that WikiHouse is light enough to handle. You can literally carry it and maneuver that into place. So you can see that really nicely and clearly there in that extension in Lincoln. So that's really great. The next very exciting partnership I'd love to mention is with LifeSpace Cabins as well. Yeah, thank you. So yeah, LifeSpace Cabins are in the southwest of the UK. They are an exceptional team of architectural designers. They also, assemble and deliver the cabins. So they are, a full team of leading experts really in that area. And we've been excited to work with them to create some custom elements and essentially give them a kit of WikiHouse parts that will work for their designs. So we've really enjoyed that partnership. You can see in the images here the first WikiHouse and LifeSpace Cabins build. Gorgeous site location down in the southwest. And as I say, they will be interested in anybody that would like a build with them across the UK, really. So I would encourage people to have a little look at their website and socials and just see the diversity and the varied nature in their cabin designs. Really beautiful. Okay. So the next project is a forest classroom. So we're working alongside WikiHouse manufacturer Mahi's and also Wood Lab Co-op to create this educational space, this kind of versatile space for Wood Lab to be able to bring people into and have workshops and engagement. So that's really lovely. Wood Lab are leading on the assembly of that as well, which you can see in the image there of them inside the workshop, bringing those parts together.
We'll be sharing more photos of that as it emerges on Instagram, I'm sure. Yeah.
Liverpool John Moore Uni, amazing group of people there. They have been working alongside Makerere University in Uganda. So we have supported them in creating a set of modified custom components that work better in a tropical climate. That's been a really lovely project. It's been really enjoyable working alongside them. They are in the process at the moment of building the first housing prototype, the idea being that it will be a house that is affordable and something that people will be able to kind of build into and expand over time. So pretty revolutionary. And, you know, as I say, it's been amazing to work alongside them. Over in New Zealand, New Neighbour are very busy completing their first WikiHouse residential house. And this is something that they're planning to develop further and offer across the country as well. Over in the Netherlands, the first, WikiHouse housing estate really, I'm delighted to say has now reached completion. So that's very exciting. So gorgeous image there of the variety across the estate really. So yeah, District Maker in Almere is wonderfully complete. And then sort of, evolving, I guess, in the Netherlands now from that first ever example of a WikiHouse build. Nick and Hendrix Koppelman's Bauer Group have been busy testing Skylark and have built a pavilion with the students at Avans University. So we've got some great images there of the students getting involved in that build and creating a completed structure very quickly in a short amount of time. So yes, as I say, what has just been working so well for us through these projects, through these partnerships, has been that we've been able to really take on board feedback. We've been able to create, as I say, custom parts and elements for people that fits their needs as well. And we've been able to really support the utilisation of Skylark across a really diverse range of projects globally. So we're thrilled about that, and it's really great to see that Skylark is out in the world. Some of the feedback and the developments that we can capture here are the redesigned gable end walls. So a simplification there in that is now a solid element that can be brought in over the top of the walls. So yeah, the bow tie connections as well, which everybody knows is the main way that we obviously bring that frame together. We have all timber connections in a WikiHouse frame. So the geometry of that has been simplified and the connections have been simplified as well. The lintels within our window and door blocks are now integrated within those parts. So that's like a library reformatting that we've done in-house now that will sort of match the lintel with the opening, so that helps. What else? So window blocks work in either axis. Yes, window blocks work in either axis. So
yeah,
axis meaning they could be moved along the different elevations now.
Yeah, but so basically, in summary, I think all these updates were in the current version, which is 0.2.2,
Right.
And I think the previous version we had, the windows were the gable end windows were specific to the gable ends, and you couldn't move them into the orientation. So, but yeah, pleased to report that's been really helpful design-wise on a lot of these recent projects.
That's it, yeah, and the addition of skylights and the examples of blocks that have asked for repeatedly as well has been included within that, so that's good. Okay, so yes, moving forwards onto Skylark 1. Yes. The idea being that this is capturing, as I mentioned, the sort of on-site feedback from that sort of volume of projects and the real world application of it. So taking it from being a digital concept into real world construction projects and absorbing that into the design. So Clayton, by all means, if you want to mention kind of what those updates looked like.
Yeah, happy to. I think we're just going to sort of take a moment to sort of jump into some more geeky details, I guess. But hopefully it's sort of useful stuff and gives you a sort of good indication of where the system's headed. None of this is really sort of baked into the library yet. It's all sort of work in progress stuff and also subject to change. So like very open to other bits of feedback that come out of the community and those watching now, so we can include them within this next round of updates. Which is going to be a quite significant one, because the whole point of getting to version 1 is to say, look, here's a stable version of Skylark. Here's the best of what we've built and tested over the last few years, and everyone else has contributed to, and that we're very sort of confident in its all-round abilities across the board. So a few sort of things to highlight, I think, that have been feedback really from you guys, from the community, and some feedback we've sort of been able to observe hands-on in the projects we've been involved in. The obvious one is that we want to include more roof pitch options. There's always been a sort of quite a limited range within the standard library, and so we're looking forward to sort of building that out with some more variety rather than just 42 degrees and flat, essentially. One of the big things that has come back from some of these recent projects is that the internal ribs that feature on the blocks have been a bit tricky to work with, particularly when it comes to installing the vapor barrier. I'll go into a bit more detail on that in a minute. The other thing is the corner posts that we have aren't really sort of featuring structurally in the design. They're sort of just there to sort of fill out that space. So we wanted to see if we can make those sort of more integral to the structure and sort of more useful in terms of the way the building performs. Another big sort of challenge has been installing the internal vertical bow ties, so these ones along the internal face. There's always been a bit of a challenge with access to that, so we want to make sure that we can make that easy to fit, because they're doing such a useful job there that avoids the needs for sort of brackets and screws. And then the end blocks, which are currently sort of separate blocks, we want to be able to find a way of making those some more accurate and more aligned and less fiddly to work with. And then recently, on some of the pitch roof designs, we sort of need to develop, I think, a clearer strategy in terms of how the pitch roof blocks are lifted and fixed into place as well, and what that means in terms of mobile platforms or step ladders, etc., on site, and how to mount that to the ridge beam in a way that's safe and doesn't require a large team of people. And then looking at tolerances of blocks as well, so I'll sort of jump into the details there, and also then the tolerances around how that fits to the foundations. So all of these are sort of, I guess, sort of micro frustrations when you're on site, and we want to try and make that process as smooth as possible for assembly. So you're not having to spend time trying to like fiddle and tighten things and try to get things to fit. So first one, internal ribs. The current version has these sort of protruding battens internally that we were using as a sort of structural element, and had these notches into the side panels. Basically, we've sort of run the numbers structurally on this and found we can remove these internal tabs and then create a flat surface that makes it really easy to fit the vapor barrier across the whole internal face. And that means that you're going to probably get better airtightness performance. You've got sort of less time cutting and taping barriers around. And we then default to a standard internal batten, like you would with any timber frame system on the inside, to build out that surface cavity instead, which will also give it probably better fire performance as well, which we will be testing. Fitting insulation, this has always been a bit of a headache in the workshop. It's because of those internal ribs, essentially. We've had to fit insulation from the side, as you can see in this picture, the blocks sort of on their side, which makes it quite tricky to do anything with soft insulation because it's hard to sort of stuff it down those gaps. A big shout out to Piyush at Mahi's, who's done a lot of testing with this recently and uncovered some of these issues. So when the redesigning of those internal ribs, and also the same with the floor beams, is let's make the internal panel the last piece that goes on. So you can remove it on site, even if you wanted to as well, insulate on site. But you could, within the workshop, it just means you've got a sort of nice open cassette to fill with insulation. You can make sure there's no gaps or sort of cold bridges across. Which definitely speeds things up as well. So just touching on the internal bow ties. So this has always been quite a tricky junction where the floor meets the roof. Floor meets the wall. And there is, we've always had, in the previous version, current version, we have got a sort of small cavity that has been basically the width of that service zone. But that makes it really difficult to fit these bow ties into that you need a sort of wedge piece of timber and a mallet. And it just means that actually sort of getting them to the place is quite fiddly. So we wanted to make that gap bigger, make it at least the width of a block of insulation, if not more. So I think 150 mils is probably the sort of sweet spot. And then have a small capping piece that we can fit on top to close it off and make a really sort of flush internal finish. Again, makes it really easy to wrap internally with the vapor barrier. And and actually sort of pushes the bow ties quite neatly into place. You've also got more access now for screwing into the sole plate from inside, because you can actually, if we make that gap sufficient enough, you can actually get a power screwdriver into there and put screws through from the inside face. And then one of the biggest changes will be around the end blocks. So I mentioned the sort of misalignment of the smaller 600 wide end blocks I've had previously. What we're sort of going back to is just having a one large beam, really, an end beam that includes all those end blocks together and includes a bit of the floor section. And the reason for that is that it essentially makes it that we only need the vertical bow ties, not also horizontal bow ties across that joint. So again, like the floor blocks, you can remove that top face. You can fit your bow ties, put the extra insulation in, and then close off the floor beam once all that's in place, which makes things a million times easier than trying to do this around all those little gaps and then insulate those gaps as well. So this is going to be quite a big step forward. It may have some sort of slight effect to the overall grid. That bit we're sort of testing out, remains to be seen. In terms of what dimension we make these end beams, obviously mindful of them not being too heavy, but the cases that are always going to be used is only in really first or ground floor and first floor sort of levels. The roof is sort of a bit of a separate thing. And then looking at the foundation connections. So again, this is around that same sort of junction where the sole plate meets the existing structure. This is probably the least resolved bit. We've tested out sort of various versions of this on different projects and trying to find really a sort of common standard for what the sole plate needs to be, the depth of that, and how to sort of fix everything in from both inside and the outside, while keeping it as a nice sort of closed cassette, closed area that's going to be well insulated. So this is on a recent project where we've wrapped with a DPM and then fitted screws on the inside and sort of blocked out the rest of the timber that we didn't need that full width of that cavity as a sole plate. Also fitting DPM, a shooty DPM to the underside of these beams as well before you install them. So, obviously, it's really hard to get access underneath unless it's really high off the ground. So doing that beforehand saves you a lot of hassle, and you've got a sort of protected underside then, which prevents any sort of moisture or insects and things from getting in from underneath. But this is something where we definitely welcome any sort of input and thoughts as this develops in terms of what size this notch needs to be, or whether we need to notch it all, and can the whole structure sort of sit just on a sole plate. But of course, that then means you're raising the floor sort of level up quite high. So it's trying to sort of balance those things, and each project might have a sort of slight difference, but where possible, let's see if there's a sort of common solution. Then I think one of the last things, corner blocks. This is sort of related to the end block change, really. So corners, as I mentioned, were these sort of square posts. Now, it probably makes more sense if we join them into a wall block and make a sort of a larger wall block that actually performs sort of better structurally. Means less bow ties, less connections, and less sort of different pieces on site. And then one of the sort of recent bits of feedback, particularly when we're doing sort of longer structures, is that even within the best conditions, the blocks are within 600 millimeters wide, and they're all stored and dry, and they arrive neatly onto site. You've still got sort of these small micro gaps, I guess, that occur between each block when you're putting them together. And over the course of a maybe 10, 15, 20 meter long building, that all builds up and you end up with a few centimeters extra length over the building than you wanted. So we're trying to sort of find the balance point, I guess, to undersize those blocks slightly in the cutting files, so that when they all go together on site, they're pretty much identical to the design model, which is, yeah, there's a bit of a sort of sweet spot there in working out exactly what there needs to be. So, and that's obviously if one block is out, then it's also going to be the whole section out, so the roof block and the wall block, and trying to make sure those all match together. So this should resolve that. And this is particularly sort of, I guess, pertinent where you've got quite tight site conditions, or you're trying to match an extension to an existing building, as we found in this case. So you really need to make sure that the overall dimension is pretty much as was designed, or as is in the drawings. So yeah, that should, by undersizing those slightly, we should be able to account for any of that tolerance buildup. I'm going to hand over to Alistair, who can probably take us through the sort of details on the WikiHouse supply chain and what that means.
Cool, thanks, Clayton. Hey everyone. Yeah, so I mean, hopefully the picture you're getting is that it's quite cool to see WikiHouse Skylark sort of really evolving into a kind of much more mature system that just kind of works, and we just keep sweating this more stuff, because that's the stuff that matters. That's the stuff that makes it work. But meanwhile, while that's kind of approaching this Skylark version 1, it means that more and more of our time, particularly in the last year, I'd say, has been focused on the invisible stuff behind the scenes, which is the kind of building that supply chain and how that's going to work with WikiHouse. And here, as with the product, we're doing R&D, we're innovating to kind of work out what works, but also I think we're not just doing something to work out what works for us, but actually, oddly enough, as I think hopefully you'll see over the next few minutes, I sort of share our thinking on this. We're kind of working on problems that I think everybody has, or that lots of people have, and so, you know, hopefully that will make it kind of interesting while I go on about this stuff, which could otherwise be incredibly dull. Let me take over the slides, shall I? That might make things easier. There we go. Cool. So, and obviously, you know, one of the big sorts of innovations, if you like, of WikiHouse is that WikiHouse is not tied to a single company. This makes it quite unusual in the world of industrialized building, is that most of these sorts of innovations in general tend to be kind of, you have one product, one supplier. And obviously WikiHouse obviously breaks that mold. And, you know, as we've always said, we're not trying to make one company. We're trying to make 100 companies. We're trying to make 1,000 companies. We're trying to kind of build capability and allow small businesses collectively to become a kind of powerful force for building better in the world, basically. And the most obvious articulation of that, of course, is in WikiHouse's manufacturing model, which everyone who's here is going to be very familiar with. The kind of the difference between a kind of conventional volumetric centralized manufacturing model, where you have a huge factory that costs millions to set up, versus at the other end, sort of this distributed, local, often flexible factories. So factories who are producing WikiHouse blocks, but not just WikiHouse. And also there's a sort of middle model as well, which I think lots of people are using, which I guess, you know, sometimes gets called sort of flying factories, or you could think of it as manufacturing as a service. Now, none of these are good, intrinsically better or worse. They're all good and they're all interesting. But actually, we're feeling pretty good at the moment about the distributed model. It has certain advantages, right? Because we're using factories and capacity that's already out there, that's already local. And oddly enough, it's all the signs seem to be that it's not just the kind of right thing to do in terms of kind of building capacity, but actually it's weirdly kind of working quite well. Because one of the things that's on a lot of people's minds at the moment is, unfortunately, we keep getting again and again and again these headlines, which is, you know, loads of investment is going into transforming construction, and then unfortunately a year or so two later you read another headline that says, sorry, this thing is folding, and it's kind of a bit depressing. And actually, weirdly, that's translating through to people who want to build. So one of the things we've heard, particularly from larger potential builders, so for example, housing associations and councils and people like that, is that resilience is a big worry for them. So we're like, i.e. they're worried that they might start kind of moving towards using a building system, but then the company goes bust and they're really stuck. So actually, weirdly, this is becoming a kind of a really useful thing for WikiHouse, that it has this resilience. It's not just one factory and one set of suppliers. So that's kind of all quite promising, really, that actually this kind of distributed model seems to be quite good. And so in the kind of the first part of kind of growing that WikiHouse supply chain was we created this kind of these agreements that we have with manufacturers, who are not surprisingly called WikiHouse manufacturers. So I'm going to talk about 4 types of agreement that we're growing within, that we're having with people within as we're building this network. And WikiHouse manufacturers is obviously the first one. It's the one we've had for the longest. We've got quite a few of them now, both inside in the UK and beyond. And that's really, really cool. But what does the same model look like for all the other services that are around building a house, basically? Is a kind of interesting question. And here, and apologies, you're going to have to bear with me because I'm going to go off on one, as I sometimes do, onto a kind of slightly meandering thought journey here, where I kind of think about, why does this work the way it does, right? When we think about conventional, the way that we procure construction, generally, we have a series of stages. We've got a customer comes along, you design something from scratch, very laboriously, guessing in the dark. You then go build it again, working it out somewhat on site, quite a lot, often a lot of the time, and then you finish it. So often what tends to happen is that you will go out, you have separate professions, right? There's separate professions who you'll go. So you'll get an architect, and the architect doesn't necessarily know who's going to build it or how it's even going to be built necessarily exactly, or how much it's going to cost. And then you'll get a structural engineer who checks it, and the structural engineer could check anything, right? And then similarly, you'll go and get builders. And all of these are general players, right? They're not specialists to a particular way of building. They work with all sorts of ways of building. They're not specialists in any way. And in a sense, that's an advantage. But the problem is, of course, there's a huge amount of communication overhead. I guess we're all familiar with some of the problems. Conventionally, when we move into the worlds of manufactured building systems, and particularly those big, large models, the kind of go-to favored model is this completely vertically integrated model, where instead of that, you have a single company who does everything front to end, and you have the sort of efficiencies and feedback that come with that. And that is a fantastic model, right? Because you get that sort of vertical integration, but and it's continuously learning. But the catch of this is it doesn't scale very well, right? For really obvious rates. The only way to scale is to just get bigger and build a bigger factory. And if you've got more customers in other sites, and it can really quickly, its bandwidth can expand. So often you have to have a bit more kind of one size fits all. It's much harder to kind of internationalize, take overseas or to different territories and things like that. So that's the kind of downside of this model. It's quite a significant downside, because it means in order to be able to scale, you need to go big. And the moment you go big, of course, you become much more vulnerable to a downturn. Hence why, unfortunately, we often see these headlines where large companies run into trouble. So I guess, and this all looks like, well, a bit world, but essentially what we're talking about is saying, well, look, there's lots of projects in different places happening side by side. So what is vertically integrated and what can be horizontally moved across? And again, one of the essential points of WikiHouse is to say, hey, all of these businesses, by working together, they might not have individually been able to do all the R&D, sweating all those details of developing a product, but actually through WikiHouse, essentially we can all collaborate. And we, Open Systems Lab, have the WikiHouse team, who are essentially a central R&D team, kind of coordinating that R&D process centrally. So we can have this kind of shared R&D lab, basically. So different companies in different places, different projects can all have a shared system. And we can take, as we've talked about, the same basic approach to manufacturer. So you can have local manufacturers all using that same system, fine. And to some extent, you can play the same thing out for some of these other roles. So one of the next barriers, as the manufacturing network of WikiHouse began to grow, one of the next barriers we found is that, not surprisingly, you needed structural engineers who were somewhat familiar with the system. So new structural engineers would come to it and go, whoa, what's all this? This is all a bit new. And so we realized what was a real need was for the next type of kind of WikiHouse role within the supply chain, which is a WikiHouse engineer. So that's a structural engineer who's familiar with WikiHouse and can check and run the calculations and sign it off to meet the building codes and regulations in a given jurisdiction. And again, that kind of works, right? You can have some specialists. You don't have to be just one company. You can have a handful. Don't need that many, but we need generally at least one in every jurisdiction. So we've created this role of WikiHouse engineers. And again, like everything kind of through this, we're kind of, working with them to kind of try and optimize and improve this process. Okay, cool. But then what about building the thing, right? So we can say checking and manufacturing, we can somewhat do those. And generally when you actually come to contracting, we're tending to use the conventional model where you produce a design and then you take it out to tender and you say to contractors, hey, here, can you tell us how much it would cost us to build this? And you would think that WikiHouse, any form of innovation would be good news, because it's like, hey, this is going to make life easier, right? But in fact, this is where we encounter what we refer to within the team as the procurement problem. So essentially, you go to a conventional contractor and they look at it and go, what's this? A technology that will make my life faster and easier and potentially save money. That's going to cost you. And the reason for that is because it's new, right? It's different. The whole point of WikiHouse is you're doing a bit more work up front, but then you get the payoff because it's so much quicker to build on site. But if they've never used it before on site, they don't know that. They can't guarantee that. So they can't bet on it necessarily yielding those savings later, because it's fast, everything's straight, it just goes together. So what we tend to see happening in projects was that actually WikiHouse was coming in sort of unfavorably priced, actually, sometimes about the same price, but certainly in many cases unfavorably priced because of this issue. And so the kind of next one obvious way that sort of began to be clear that we could do this to try and address this issue of it being overpriced was to begin to develop a network of builders and particular installers who are familiar with WikiHouse and are ready to go and build this. And they could have multiple roles, right? Because a WikiHouse installer could be a company who will act as a full contractor on a whole project. And there's certainly some companies emerging who are doing that. And once they've used it, they know, hey, no, we really can go on site and build this thing in a few days. This is great. And they can just get better and better at that. But also in potentially some of the large projects, it might open the door to some of the larger projects, because it might mean that if you've got a larger general contractor who's not sure about that thing, you can say, don't worry, you can outsource that bit. There's actually a small or medium-sized enterprise who's perfectly happy who's done this before, and they would actually be perfectly happy to come along to your site, do just the chassis assembly bit, and then leave. And that's sort of an option that we see some people exploring at the moment on potentially some larger projects. So really a kind of, really, really important role. And ultimately, the people who are going to build it are the ones who really understand costs, because they're the ones who actually have skin in the game of, of those things. So cool, we had this idea of installers, we've added this. So we're starting to build these kind of roles within the WikiHouse supply chain. But it's here that we get to the last kind of big remaining problem, right? There's still a big gap here. And there's a couple of gaps. So one of the gaps is design. And we previously explored, if you look at the WikiHouse website right now, for example, it reflects this idea of kind of building, creating a role called a WikiHouse designer. But what we found is that wasn't necessarily solving the problem, because the designers don't have access to that cost information either. So to a large extent, the designers, although they might be familiar with WikiHouse, are still kind of a little bit in the dark, and that wasn't really solving the customer's problem. what customers really want and need, especially less experienced customers, is somebody who can give them that certainty and can help them go through the whole process. So partly it's about design, and this of course is part of that historic role of the role of architect, is that partly it's about design and building something and helping the customer through that journey, but it's also, a lot of it's just to do with project management and knowing all the things that a project has to comply with. It has to meet with building regulations, it has to comply with the planning codes and so forth. So there's so much of the work of a project which is that vertical delivery mode. And this, in a way, is why I've chosen this rather convoluted diagram with all these, looks like a kind of tartan thing with horizontals and verticals, is to try and kind of emphasize this diagram, is that there is huge value in the horizontal. That is people who know how to do something, specialize around a product and can really help people almost anywhere. But there's also real value in that deep vertical integration, which is a single company that will help a customer get from A to B and can build a kind of iterative, continuously learning service model essentially around that. And it feels like that's the thing that's really going to transform construction and is really going to allow zero carbon construction to actually make more carbon intensive and less good models of building obsolete ultimately. This is the kind of key role that we've identified. And so what we're going to be testing is this fourth role, which we're calling WikiHouse design and build teams. And certainly this is kind of picking up on a pattern that's already quite common. So in other building technologies, like for example, SIPs, we kind of have seen these companies emerging who are really well branded products, really well branded companies. They're not necessarily tied to a specific product, but they offer this complete design and build service. And what that allows them to do is to guide the user through, guide the customer through that journey, to give a bit more cost certainty, and to just kind of help make sure that projects get delivered. And of course, there's huge value there as well. So it's really challenging, but if you can innovate around those processes, there's lots of money to be made as well. So yeah, WikiHouse design and build teams are able to do all these things. They can support customers all the way through. They can provide as much cost certainty as possible based on real costings. In other words, it costs us this much to do that. It cost us that much last time. So actually, we're willing to bet we can do it. We can improve that slightly or whatever for next time, which allows us to make better zero carbon, more innovative forms of construction, cost competitive, and ultimately to outperform other modes of construction. They can outsource. So I think this is really important. So if you're thinking about maybe becoming a WikiHouse design and build team, it doesn't mean you literally have to do everything yourself. You might outsource almost everything. So certainly you kind of could go to a WikiHouse manufacturer to do the manufacturing. And actually we find in our early explorations of these, we're obviously working with most of these things, companies in terms of supporting them in doing things like chassis design and things like that through the design process. So it's not about them having to do literally everything themselves, but ultimately they are the thread that takes people all the way through the project and make sure it gets delivered across both design and build. I think another thing that's worth mentioning, because obviously we know that in the WikiHouse community there's loads of architects, and they're like, well, wait a minute, what's our role? And so I think the reason why we've called these design and build teams is to say, well, actually, there's loads and loads of scope here for architects to team up with building companies and set up a local WikiHouse design and build team and say, actually, we can work together in partnership, and actually they can collectively kind of be two halves of that agreement to provide the same outcome. So again, it might be a bit different, a bit innovative, but we think this is actually potentially going to be the key to making this work. But we are definitely going to be testing this and exploring this. Like everything that we do, we kind of prototype, we kind of learn, we work with people, we listen, we find out what works, and we all keep developing this. And so yeah, you will see this kind of emerge on some forthcoming updates to the WikiHouse website. There are these 4 key agreement types, so go and check out more about those there. obviously please do ask us if you're interested in any of these things, or have questions about them. It'll be really fun, and we'll figure it out.
Amazing. I wanted to just add a little bit on top of that as well, Alistair. I think in terms of, kind of this feels like a very natural progression for us, I think, in that we've been building relationships between ourselves and the individual kind of parts of delivery in projects. And we've wanted to really kind of encourage people to kind of build those relationships inside of the WikiHouse community to, as you say, to kind of streamline and support project delivery. So it has felt really like a natural progression to the point that we're up to now. And it is also really drawn down from project experience and having, infinite numbers of project types and scales, and sort of fathoming what the right delivery model is to achieve that and to achieve successful projects that we can utilize WikiHouse. So it's really nice to kind of have this clarity, I think, at the moment.
And talking for community, I can see lots of members joining the chat. We've got people from Chile, the US, Scotland, all sorts of places. Thank you so much for your questions. So I'm going to start you guys with one question about the system. So maybe this one's for you, Clayton. And it's around whether the new Skylark version 1 will be compatible with previous versions.
As much as possible. It remains to be seen entirely. I think one thing that might change is because we're getting away with the internal 32 mil sort of cavity gap that we've got that's caused by those internal ribs. By doing away with that has sort of flow-on effects for the end beams, and so it depends on the sort of design of the end beams and the corners and how that's going to work. So it may be the case that we would actually just reduce spans ever so slightly by 64 mils. So they might be slightly different to what they were before. Overall, the heights and everything else will be exactly the same. The grid set out, the 600 mils could be the same. It's going to be minute tweaks at certain ends. If there's a particular need to, I guess, have some integration exact match up with between, say, mid-project, right? Then we can sort of maybe find some workarounds that might help you. But it's going to be more or less like a sort of like swap out.
Okay.
Backward compatibility is really hard. Still blows my mind the fact that the first Lego block, you can put a Lego block made today on the first Lego block and they fit. I don't know how they did that.
Yeah, if you guys have any specific questions about projects, either pop a question in the community or contact us directly. So we've got a question. Let me show it on the screen. What generation is Skylark? What year did it become standard?
It became the sort of core system, I guess, that we were working from 2022 when we launched. Before then, it was very much a sort of like test bed. We had hunches at that point that it was going to sort of do better than everything else. We had started with Wren here in the UK, and then sort of moved on to Blackbird, which is like a post and beam style like prototype. But then we tried to combine the best of both of those worlds really into Skylark, which is, we know that beams work really well. We know the columns work really well. Let's create a lot of simply supported beams as cassettes and stitch those together.
Yeah, and I think we started developing it a while before the launch in February 2022. So it's been like 2 years and a bit.
By the way, yesterday Mel shared a photo of this thing like 2 years ago, and we all looked really young, and it made us all really sad.
Our friends at Live Space Cabins asking, have you ever tried blown insulation like warm cell cellulose, waste paper, matter?
Not at any scale. We know other sort of similar cassette systems that have used it. The one sort of thing that's put us off has been you have to insulate on site once the bow ties are in place, because if you do it beforehand, you've got all these gaps where the bow ties are, where your insulation's going to leak out. So unless it's particularly dense, you're going to have to do it on site, which comes with its own costs, and whether it's what makes more sense. Is it better to do it in the workshop and have that sort of already done by the time it gets to site, on site? There may be some modifications generally across the system to make that work. For instance, we've got these like horizontal noggins in all the blocks. which essentially separate those compartments. So you're going to have to either fill each one individually or sort of remove those somehow. So it's not currently geared up to cellulose entirely.
We'd be really interested if you try it though. And the other thing about this was the economics. I remember when we did look into this, certainly at that time, the weird thing is that the kit isn't that expensive, but as a service, it's quite expensive because you're paying someone to come in and do it. So it's definitely worth trying. And then it would be the case of like, get your own kit, probably, if it does work.
That's great. Thank you. We've got another question here. And just a reminder, if you have any questions, just pop them in the box and we'll get to them in a minute. Regarding the bow ties, are they purposely designed with the angled edges not having a tangent relationship to the radius corners? Asks Andre. Who wants to take that one?
I'm just trying to, I might need a sketch.
This is the problem of describing geometric stuff in words. It's really hard, isn't it?
They are very purposely designed, all those angles on there. They've been tested to that point. There's records of all this testing on the website and the research page. And it's been a case of sort of iteratively working out what that opportune angle. If you see photos of the original sort of Skylark builds, the first ones we did, those bow ties are about twice the size and and sort of angled differently. So we wanted to reduce them down because they're small, they're each quite effective, and adding more is good. If we make that angle any sharper, then it becomes sort of problematic in terms of it gets too close to the edges of the sheet. And if you make them too shallow, then they don't sort of do their sort of attachment pulling action. So
exactly. And just to say, obviously the bow tie connector has been tested extensively and is an element that kind of knits and marries those components together. So the design is kind of first informed by that kind of structural connection property.
But if you want to send through a little drawing exactly where you think might be an issue in there, or something that you're querying, then we can look.
Yeah, maybe even better post in the community and then we can all see the answer. He also has a question about the spacing of the bow ties being 194.9 millimeters rather than an even number.
This might be a case of tolerances being applied, but all these things are going to be sort of hashed out in the new update. We're building a better sort of internal system for, I guess, managing that whole library of blocks and providing those updates more rapidly. So
in general, aside from the tolerances thing, right, which is the 0.9 bit here, the actual spacing of them was, Gabriella did a really cool exercise where he was sweating exactly what is the optimum so that no part, either the bow tie or the bit left behind, is weak. And so it's kind of what is the maximum on that. So the dimension is very much driven by that. But yeah, the 0.9 bit sounds like 2 times a 0.5 offset.
That's right. Just to say a little more on that as well, it's a part of the structural frame, those bow tie connections. And so when we look at custom designs, it's a conversation that we have in-house with Gabriella, who is the structural lead, to say, is there enough bow tie connections? Are they in the right locations? That kind of thing. So that element is serving a vital purpose within that frame performance.
Yep. We've got a comment actually about the tolerance buildup. When assembling a house, the final sections need energetic use of a big mallet. And I don't know where you are called analytical, but I think you've built a wiki house. So tell us more in the comments. We've got another question from Urban Collab Architecture. Can I use your structural analysis to educate my US engineer to provide compliance with local US codes? That's a really important question.
I would say definitely. So what we encourage is for structural engineers to first read through those documents on the website. If your project is gaining momentum and the consultant is on board, we have our own, as I say, internal structural lead who is there to support that kind of translation of information. We have been working on a number of projects in the US and have supported that translation of data across to US projects. So that's definitely something we can support with.
Amber, countries, would that be the same.
Yeah, Amber, am I right in thinking Gabriella has just done a piece of work which was exactly this? It was translating the structural analysis into things that will make it easier for US engineers. I don't know if it's on our website yet, is it?
I'm not sure. It could be part of consultancy work for projects, because it could be tailored to individual designs. So definitely reach out.
We'll get it onto the website, but if it's not on the website yet, drop us an email.
Just, have a conversation with us, definitely.
Yeah, we have got a question from Hugo. Let me just show it. Do you think there's a good opportunity to use Skylark to help extend and retrofit existing housing stock? Who would like to take that one?
So you'll see from the project examples, the first project, just in a really simple way, that Skylark is being used to extend existing houses already. There's no real limitations with that, because even if you're matching existing floor levels, you can kind of substitute out your foundation design to suit what sort of floor level you need to match. So it's kind of can be tailored to the individual house design as needed. Sometimes we can have challenges if the wiki house wall is very close to a party wall and you can't get the bow tie connectors in externally. That's the only time where I feel sometimes we have to kind of advise again as a consultant on how to ensure that wall is, integrated as part of the frame. Everything is connected as it should be. But there's definitely lots of opportunity to use WikiHouse in small sites, tight sites, expanding existing houses.
Shout out to Nick Havers and Hendrix Bauer, who did some work exploring party walls and fitting bow ties internally, which is very cool stuff. So we'll see if we can try and get some of that into the standards for suite of blocks.
One of the issues, with extensions, the obvious issues is the interface, right? In the sense that WikiHouse is very precise and most existing houses aren't. So in the same way that the rails underneath a WikiHouse are the interface between, if you like, the ground and the precision of that chassis, and they have to be straight and they have to be level. I think that extension you showed in the video, Amber, the way that was done, right, was by fixing a similar style rail, right, onto the existing structure that then sort of absorbed that tolerance, that difference.
Exactly. So you're looking at architectural and structural design as part of that. You've got to think how that is going to join against the existing house and the details of that junction. Exactly right. But it's been done, and it's a thing that can be achieved. The only examples where I'm less keen on using WikiHouse to expand existing property is when the design intention is very, very complex. Sometimes I think we have a habit of extending an existing property and bringing sort of everything, kitchen sink approach, bringing so much into it with different features, and it can be overly complex. So we always encourage rational design, efficiency, maximizing space, good balance of light. That's it really. So it's definitely there for those use cases.
We've got one comment from Ron about cellulose. I'm just going to put it there. They want to use dense blown cellulose for the next project. The supplier wanted the bow tie 2 centimeters larger for the hose. So thanks for sharing that, Ron. I don't know if you want to add it to the community, and then we can maybe have a bit.
I know other systems, what they've done is just put a separate hole in the middle of the panel, and it's a question of how many you have to have at height to make sure that et cetera, and then you just make a bung for it at the end, so you don't have to. Well, I like the idea of using the bow tie holes, though. That sounds fun if it's possible.
Yeah, great. We could do something about that. I've got another comment actually about cellulose, from somebody who had a minor rodent problem, but they were using rock wool. I'm not sure if the mice would have preferred cellulose.
There's something in architectural detailing on this as well. I think it's important to just always mention that any cavity, any gap that is, rodent friendly should be covered, with insect mesh or, a physical barrier of some kind. So that's the first port of call, is to try and ensure that the frame itself is, sealed and secure, including outside of the WikiHouse element, any cavities with your cladding. That's another, classic thing that happens in construction projects generally is behind cladding, you'll get insects and things making homes there. So that's a sort of a general kind of architectural design comment. Also, I guess, the nice thing about the system developments that we've absorbed over the last sort of 12 months is that the frame itself is it's sealed, like, it's a continuous external envelope. So cavities and gaps and things are not a thing in the current Skylark design. So that's good as well.
Yeah, thank you. We've got time for a couple more questions. So I will ask you this one here. Can a sheet material with a VCL layer be used for internal panels such as Medite, Smart Ply, Airtight? Or will this cause problems considering two different sheet materials will be used for one block?
Yeah, that's really interesting. I think possibly worth exploring. The considerations there, I think, are that there are lots of little dog bones from the CNC machining, so you're going to need quite a lot of tape to get into that way, and the tape's the expensive part. So I think it may work out more cost effectively to just put a layer of wrap over the top, even though that's maybe a bit more labor,
I think so.
and minimize the amount of tape you have to use. But yeah, I'm not sure what the cost difference is between the airtight versions of the OSB panels and the non-airtight versions as well.
We discussed this in-house. We also felt that to separate the internal panels onto sheets specifically with that integrated VCL layer is kind of, there's almost more work in doing that on the desktop than there is to just apply a typical internal membrane. So it didn't feel like an efficiency step, in our opinion.
Well, just to explain what you mean by that, in case it's not obvious, which is obviously on the cutting files, those two pieces of a block will probably be on the same sheet. Yeah. So it could be done, but obviously what you'd have to do is disaggregate all your things. Certainly possible, right? If you're doing a build, especially a build which has lots and lots of repeat components, repeat blocks, the same standard blocks, you could definitely do that. Yeah. But as you say, for all these reasons, it might not be cost effective anyway to do it.
Yeah, if you have any more questions about that, please put them in the community. And anybody else, just join the community. We check it every day, answer questions there, and everybody can see the answers. One final question, timings for version 1. When do we think it's going to be released?
Yeah, we did mention that. It is early next year. I mean, there's still a bit to work out. There's still stuff that we want to sort of get feedback from some other builds. But and then the actual job of updating the library across the board. But we're in a reasonable place where I think we can say within the first couple of months of 2025 we should have it out there.
It's also because there's the bit which Clayton is not saying is there's the R&D element, but actually once we come to do a release, there's a huge amount of work. Where we just sort of have to down tools and do all that. And of course, we love doing that. So obviously in an ideal world, and hopefully more and more into the future, that will become so much easier, right? Because we can literally just say, this is what we got, here we are, go. But actually what we find is that obviously we want to make sure that when a release goes out, it's as well packaged as possible, because people will use those things. So there's a bit of work in there. So
and people use them straight away as soon as we release.
Exactly.
We get messages the next day saying
there's always something that we miss as well, and so we're always really grateful, because every time we do a release, usually within the first 3 days, a load of people say, "Oh, I spotted a mistake here as well, a mistake here," which is really
and we've been collating, thanks to everyone's feedback, we've been collating a long list of like various bugs and things on some of the cutting files from the previous release. So we go to do sort of complete blanket revamp of everything in there, and also use this opportunity to add more blocks that aren't currently there to more design options, flexibility.
Yeah, so if you are cutting anything right now and have anything to tell us about it, please do. Through the
the other message there is that I guess while it's quite a significant update, it just improves what's there already. It's not there's nothing that we flagged are massive concerns in the current version. They're all just little improvements that particularly make the job on site a lot easier.
Refinements. And just to say as well that these updates are being utilised in custom projects and chassis design work that we're doing at the moment. So for anybody that is looking to kind of utilise WikiHows, feel free to reach out, and we're still here to kind of support on those projects as well. So
yes, we are. Thank you so much for joining us. We are exactly 1 hour. So yes, please do get in touch. Tell us how you're getting on with your projects. Tell us if you've got any questions, if you've got any projects in mind. We're here for you. Thank you so much. We'll see you soon. Bye-bye.